let's get started. Can you hear me?
Yes,
Yes, you're audible.
Can you see me?
yes,
And is my screen visible?
yes.
So let's get started. The first problem is you have to implement a Caesar cipher. So tell me when you're done reading this much, and I'll show you rest. Done. Those who are done, raise your hands. Okay, so let me explain this part. In encryption, there are three terms. We have plain text, ciphertext, and decrypted text. So your job is to take plain text, for example, this, and you will apply Caesar encryption to it. So what Caesar encryption does is you and the person you want to communicate with in secret, you have to decide on a key. Here your key is how many alphabets we are going to shift. Okay. So in case, as in the example, our shift is, let's say 3. So H is shifted by 3 points. E, F, G, H, I, J, K. So H becomes K. Similarly, L becomes O, L becomes O. So if both of you know how many alphabets we are supposed to shift, you know how to decrypt back, because if I give you a shifted value, you have to just subtract the same thing. Okay. You have to go back. So what you have to do is I will give you a text file, for example, this. You will take this as input. You have to read this and you will generate a cipher and write it back to a different list, for example, this thing. And then your program should also be able to decipher this encrypted text back to the original thing. And then you can compare if everything is the same. Okay. So now read the rest of it. This is how you're going to implement it. I'll give you some helper code. So read this one, how you have to implement it. If you have any questions, you can ask. you will need 4 inputs from the user, whether he wants to encrypt or decrypt. What does he want to encrypt? Where does he want to save the output file? And what is the shift? Okay, so these are 4 things. So this is the predominant way in which we take arguments from the user in Python. There is something known as argument parser. So this is very simple code. If you go through these lines, you will actually learn how to use it yourself. So this thing becomes basically the variable of what is supplied. So args, I have saved args equal to this. So if I say args.input, I will get this. Args.output, I will get this. So this is how you will take the input from the user. And then this is how you call it. Once everything is coded up, you say caesar.py dash dash action and so on. You can also specify a short form, for example, this, as we've done here. So this should be enough. So take 20 minutes at 5:30. We'll go over it together. Does anyone have any question? Cannot hear. Can anyone confirm if you can hear? No? Yeah, so Gaurav, I think there's something wrong on your side. People are able to hear. So if nobody has a question, use this code, take input from the user, and the rest you know what to do. When you test your code, maybe you can try it with maybe use a single sentence to check whether everything is working fine. I'll give you the full text here. So I pasted the plain text in the chat, the entire thing if you want to reuse it. You can choose the key yourself. So if anyone joined late or couldn't hear me earlier, you have to implement Caesar cipher, Caesar encryption, both ways, encryption as well as decryption. So the way you do Caesar encryption is you and the recipient decide on a shift, on a key. How many alphabets are we going to shift when we encrypt? How many alphabets are we going to shift back when we decrypt? Okay, so these two need to be the same. For example, if we say we will be shifting every alphabet by 3, Z becomes CRR, that is Z becomes C, O becomes R, O becomes R. So you need to implement this while taking these 4 inputs from the user. How will you take it? I'm giving you this code. You need to know whether I am supposed to do encryption or decryption. What is the path of the input file that contains the text? What is the output file? Basically, where should I store it? And finally, how many alphabets should I shift? So these 4 things. Your code should be case sensitive and it should respect spaces as well as new lines. You're only supposed to work with the alphabets. And this is how you call it. So this is the alpha function. Maybe I'll paste this as well. By the way, the arguments to the flags, that is dash dash input dash dash output, those need not be these exact same values, file underscore I, file underscore O. You need to supply the path of your file. So you can change it as you will.
क्या बात है। Baby.
Any progress? How many of you are halfway or something's not working but you're halfway there? Okay, so it's 5:30. People who are halfway done or who have at least tried something, can you please raise your hands? Maybe we can go through your solutions halfway and then we can go over the rest of it. At least we'll see how far you've got. Did only one person try? So in the chat, we have Satya. So you seem to be doing something. So how far have you got? I want to see a student solution actually. At least part of it, not all of it. Did none of you even try? I'm asking because by going through your code, I'll understand where you are stuck basically. Where is the doubt? Nobody. No, don't paste your code. Just raise your hand that you have done it or you have attempted it, and then we can go over it together. Don't paste your code here. Raise your hand if you've done it. We'll go over it together. Okay, so Neeraj, can you share your screen and maybe unmute?
Yeah, I tried this one. I was just trying to go write the encrypt method. So the first thing I was facing the trouble with was to convert this. Suppose there is a Z or a W, and I want to shift it 5 or 10 places, which will cross the uh, numbers. So I was trying to find the how to circle this, and this was the solution I was given by Google. So this, and I certainly am not able to visualize what is wrong with this one. I'm using this environment, and it seems to be printing 97 for A, and it should fall in this list, but it somehow is not entering this if condition and it is going to else condition. So if I do this, it is giving me the same result. So it is not encrypting, but it should work at least by what I.
Yes, is this. Wait, yeah, let's go over it. Let's go. So result is black, key is integer key for letter in S, print order of this, which is 32. Wait, so A is 32 in your case. So you're starting at 96.
Yes.
Yeah, you're printing the order of letter and the first letter is A. It's coming out to be 32. So it's
No,
out of A.
A should be okay. Let me do it like stepwise. So next, so key is 3. I converted it into a numer. Then for this, I printed the.
Okay, so
It
97.
is
Okay, yeah.
97. So this
Okay.
range it should fulfill, but it didn't go into that if condition.
Okay, so the way you write range, you put a dash between 96 and 1 to 2. Why is that?
Oh, okay. So this should be comma. I'm sorry, my bad. Okay. So for letter A, even now it doesn't go into this one. So
So
previous.
can you individually try maybe integer order letter? The integer
Okay.
order letter should, yeah, so can you test it out somewhere?
Sorry, I didn't get you.
Can you run maybe part of your code somewhere else to check what it's printing?
Okay.
So you have
So
VS Code.
yeah, I have VS Code. It was not giving me anything, so I thought I will come here. Maybe if I want to print something simpler, then probably I'll choose. Sorry, edit this code. I'll choose this one.
So if you run this.
So which part you want me to print? If
It's
this is.
simply integer, yeah, integer order letter and your list range 96 to 1
So if integer order letter, this one is printing 97. So
yeah, and the
97.
range, yeah.
Okay, so print this. And print.
Yeah, and exit the rest.
Okay. Sorry, sorry, I am a bit nervous. So this is not giving a list.
Okay, so instead of the braces, can you write list?
Okay.
LIST and then brackets. Another bracket here.
Okay, so this one is.
Yeah. So what that was doing is you have a list of a generator. So the list stores a generator. So it says, okay, is 97 a generator? No, it's not a generator. So it's skipping the if.
Mhm.
So
Okay.
that's the issue. So maybe you can try after that. So
Okay.
the other person was Sarmishta. Can you share your screen? Sarmishta, if I'm pronouncing your name correctly. You have your hand raised. If you don't want to share your screen, you can type it in the chat that I'm okay with that. We'll go over it together. Yeah, I think she's not interested. So let's start. Is my screen visible? Can anyone confirm?
Yes.
Excuse me, sir.
Yeah, thank you. Yeah.
Can I share my screen too?
Yeah.
Actually,
Yeah,
I
please go
have.
ahead.
Okay.
Yeah, we can see.
Okay. Am I or is it visible?
Yeah, it's visible. You're
Okay. So actually, I have prepared this code. It was. Can you just check the code, please? Is it the right one for Caesar Cipher? Because I have already prepared it a week back, almost.
prepare it with.
I'm sorry.
You said I have prepared it with.
If VS Code only, actually, I have done this code almost a month back, or a
Okay.
few weeks back. Caesar Cipher,
Okay.
yes. So
Okay.
is it the correct one? If you can just check. Maybe it's not
No,
efficient.
I mean, you've written it. You should know it. And does it run? Does it produce the output?
Yes, actually, this does run. You can check it here, but not the way you have like you have mentioned that the input should be the path there's an input should be taken from the user as well as the shift number as well as the output path and the input path. So this in this code there is just an input taken. Type your message and you can type anything if I just type my name here and I just type here a shift number 5, so it will give us a this value. Now if I just copy this one, I'm so sorry, if I just want to run this code again, oh, my mistake, sorry. Now if I just decode this, giving the same, it's not copying it. And the same shift number 5. That's it.
Yeah. So it works. So the idea was that you had to do file IO because in this week's lectures, you were taught file IO. So that was the goal. So if you had done Caesar Cipher before, you may have, I mean, you could have reused the code that did the encryption or the decryption, but I wanted you to basically read and write to files. I mean, it's okay if you've done it and you're using code, but that part is also important because writing a single letter is different
Right.
from reading a full file. So maybe you can try, I mean, reusing your code, but read the file, read the text from the file and write the output to the file. Okay.
Okay. Okay.
So let's go over it together. So first we had this code hard parse. So in Python, this is the go-to method for taking in inputs. In the first lecture, I had taught you this import sys. So this is actually not good because you don't get as much control, as much versatility as you get with argument parser. So this is a library argparse, and this is one of its methods. So the way you do it, you define a parser, that is
Yeah.
argument parser, and you
Sir, can I speak in between?
yeah.
Yeah,
Hello?
sir. Yeah, sir, can you please explain like about the arg parts and how we are using it here?
Yeah, that's what I'm going with. Yeah.
Okay, sorry. Yeah, please, sir.
Yeah. So argparse is the default method, is the go-to method that developers use in Python. So the way you do it is you import argument parser from this library, argparse, and then you define a parser like this. You can memorize this. Parser is equal to argument parser. Once you do this, you have to tell the parser, I want these arguments. Let's say I want to add an argument. I write parser dot add argument. Let's say I'll type it out myself, for example. Here we have a parser, and then we want to input. Let's say I want to read input file path. Okay, so I'll say parser dot read, sorry, add argument. And then the first thing is a flag. That is, you can either type a one letter flag, or you can type, you have two dashes and you write the full thing like this, file. Okay, so let's say I do both of them, dash a and this. Okay, so what happens is whatever is supplied in this thing will be stored in this. So this by default becomes its name, the name of the argument that I'll use. So file. Then I'll tell it, okay, is it a required argument? That is it a must that a user has to supply it? If I say true, let's say I set it to true, and we try to run it. Args is equal to parser dot parse args. If we try to run it, solution one, it will say the following arguments are required. You cannot run this file without supplying something for dash n. Okay, if I set it to false, or if I don't supply it, it becomes optional. I can run it without it. Okay, so in our case, we want everything to be, I mean, required. So required is set to true. You can tell it, okay, this is a string. So we say type is equal to string. That is what I will supply for file will be a string. In case I want an integer, I will say this is an integer. We will use it for the key. So I'll say this is a string. And then for other people who are going to use it, you can say, okay, what is this? You can say input file path. So what happens is if you are giving somebody your code and he doesn't know what to supply, he can write dash dash help after your file and it will print the help itself. That dash f file, it is supposed to take an input file path. So if we now take this part, this code, and we use it again, we'll see the entire help thing. That is A is decrypt, I gives the input path, O gives the output path, key is key. Okay, so this is how you do it. Another thing is you can specify the choices for each argument. For example, in action, I only want two choices. That is either D or E, D for decrypt, E for encryption. Anything else won't be accepted. For example, if I write dash A, I write, let's say F. And for input, I say, let's write anything for the typing. Dash O is anything and dash key is 3. So it will say invalid choice F, choose from D or E. So this is also very helpful when you want to restrict the user to limited choices. So does anyone have any questions in argument parser?
Yeah, yes, sir. Uh, Sir, when we are like we are giving some options like we are giving a dash a and it will go to the actions. And with that, if I am giving the required true, then sir, can you give us little explanation on required true and false?
Yeah, so required true says that the user must provide this argument. That is, I won't run this file unless I receive something for this. Let's say I add an optional argument, parser dash add argument, and we'll say that's dash e, and we'll say greet.
Mhm.
Okay. Say required is false, and Can you hear me? Hello?
Yes, sir. Yes, sir. I can hear you.
Yeah, was I audible a minute ago? I was so
In between, there was no voice.
I mean, earlier you could not hear anything when I was speaking about argument
Sir, I
process.
heard till required false. Your last line.
You were about to
I think
explain required false.
Yes, sir.
in this line basically.
Yeah, clear, sir. Like required
Yeah.
false and time
Yeah,
sheet.
at least someone, yeah, I somehow got muted. So I was saying we are expecting a greeting from the user basically that he should type a string and we will print it. So let's say this, and we do args, and let's say we do greeting. Greeting is equal to args dot greeting. Okay, args dot greeting back. Then we can print greeting. Notice that this is not a required field. So if I run it, same argument as before. In fact, let's. So we do Python solution one, and we don't pass any greeting. It will print none because by default it is set to none. Okay.
No.
Now let's say I do supply something. We say greet and we say hello. This time we get hello. So is required. Yeah. In case I set it to true, it won't work if I don't supply. It will say this is a required argument.
Got it, sir.
Okay. You can also supply default values for certain things. Let's say you set required to false and you also set default as hello. So earlier the default was none, now the default is hello. So you can also set default values. So let's keep on going. So we have four things. We have the action, the input file, the output file, and dash k is basically the shift. So let us store the key in args.key. We can directly use args.key and we can also store it in a different. In Python, it is a convention that if you have a constant that is something which will never change in your code, you write it in all caps. It's just a convention. You can write it small as well. If it's something that will never change, it is advisable to write it like this. So we have a key and it is already an integer. Next, we want basically the list of alphabets. So one way to do it is as one of the students had done, she had written every single letter. Another way you can do it is you can just write string and then you say alphabets is equal to string dot ASCII letters. So this gives you the list of all alphabets. First the small alphabets, then the large alphabets. So if we print this out, let's delete this for the time being. Yeah, so we get A, B, C, D, F, G, I, J, K, and so on. Okay. So this I believe is in fact the check this. Yeah, this is a string. It's basically a string where the first characters are small case letters, and then we have the uppercase letters like this. So we have this. Now we have the alphabets. We have the key is args.key, and now we are supposed to read the file. So in your lectures, you must have done something like this. That is, let's say a handle is equal to open, then you supply args dot what was it input, and you write read, and then you basically get this, and then you can do this read lines, something
Yes,
like
sir.
this,
Yeah.
right?
Yeah. Yes.
Yeah. So and then you obviously have to close it, right? Like this. But this is not the recommended way to do it in Python because often people forget this, or it is difficult to find, okay, where did this, let's say I have many lines between these two. 100 lines, I have to search for this thing. Where is the closing? Where do I close the file? So in Python, when you work with such things, that is, you open something and then you have to close that object, it is better to do this with the open. With open, and then you write args.input. You're supposed to read it as file like this. And then let's say we do the data is equal to file dot read lines. Okay. So, and then when you exit this part, with knows that the moment I exit the block, I am supposed to close this. So this ensures that this file will be closed. So this is better code than writing an open and a close statement. Does anyone have a confusion with this part with open? Otherwise, you would have written like this: file is equal to open args dot input comma read, and then you will do file dot close, something like this. So these two things are replaced by one line like this. With any confusion?
No, sir.
So we have to read two files basically. The first one in read mode, the second one in write mode. I completed now. Okay, good. So we need to read two files, one in the read mode, one in the write mode. So let's say we have one as file I, and we can do two like this. And write two separate blocks, one for reading, one for writing. For example, was output and file.o, or you can write this part here. Now both of them will be opened under the same with clause. So now both files are open. Input file is open in read mode. The output file is open in write. Now what are we supposed to do? We will read one line at a time. So let's say for line in file underscore I dot read lines. So now we have one line. So what are we supposed to do with the line? So with that line, we convert everything, we shift everything. Notice that our sentence is basically a string of characters, and we are supposed to map every character to something else. Now, a string is also an iterable, so we can utilize a map function. Okay, and our first thing will be a function, and the second thing will be the line, right? Let's say line underscore I, because this is the input line. Now we will write a function which will shift alphabet. Shift alphabet. Okay. So what will shift alphabet do? Define shift alphabet. It will take an alphabet and it should know how much to shift it by, and it will do something. Okay, we'll write it later. So now the problem here is, if you remember, in map, it will automatically take every element, single element of this iterable. But we need to supply a second argument as well. Yeah, Karan, do you have a question?
Sir, maybe it may be a silly question. So what will map function will do here?
Yeah, so map function, we use a map function when we want to apply a function, apply some changes to every element of an iterable. An iterable is a list, a tuple, anything that you can apply a loop on. So a list, a string is basically a list of characters, basically an iterable where every element is a character, right? H is a character, L is a character, and so on. In our case, we want to apply a shift to every element of that iterable. So it is essentially a mapping, right?
So it will apply to each character in the string.
Yeah.
Okay, yes.
Yeah, so we need to tell it what to apply, basically a function. So the function that we write here will automatically take whatever is basically one element of this thing, but we also need to supply a second argument. So the way you do it is, there is a trick. You supply the function to a lambda function. So let's say we have alphabet and pass this alphabet here. And we also supply the key, basically key1. Another way to do it would be that since key is global, don't keep it as an argument, leave it as is. So you have two options: either use the global value of key, or if your function demands it, you can basically do it like this. Yes, it's a trick. Like you use a function inside a lambda function and then you supply additional arguments. Okay. Yeah. Does anyone have a confusion in this line? It will take every letter from the line, it will apply shift alphabet over it, and we will get a new, basically a new line. Okay. So we can convert this into a string, and we will have line underscore, basically line out. And what will we do with it? We will write it this dot write line underscore. Okay, and I think this is all that needs to be done apart from this function. Is this part clear to everyone?
Yes, sir. Except lambda function.
Were you present in the previous session?
No, sir.
Yeah, actually, we did go over this extensively in the last sessions. We'll have to see them. So now let's write the shift alphabet thing. So the first thing is we only want to work with alphabets. That is whatever is inside this. So we check if alphabet is not in alphabets, return as is. Okay. Otherwise, what do? We find out the index of the alphabet in this thing. Okay. So let's say we have index is equal to alphabet is an iterable, so we can use this function index, and we find the index of alphabet. Now we have to shift it. So new index will be the original index plus the shift value. Okay. Plus the shift value, and we divide this by length of alphabets. Notice that this is modular division. It only gives you the remainder. So let's say let's say you have 26 alphabets. We are only working with lowercase letters, and you are on 25, let's say, or maybe let's say you are on letter 20. So 20 mod 26 return you the same thing. Let's say I want to shift 20 by 3, I will do 20 plus 3, and then if I do mod 26, so basically I'm asking it to give me the remainder of 23 divided by 26. 20 plus 3 mod 26, it will be the number itself because 23 is smaller than that. Now let's say I'm at the edge. I am at 25. So 25 plus 3 is 28. So when I do mod 26, it will give me 2. Okay. So it's basically working in multiples of 26 and giving me the remainder. So in our case, try to understand this. If the key is small, if the shift is small and I am within the range, that is, let's say I was at C. C is ABC, so let's C is 3, and I am using a shift of, let's say, 5. So this is okay. Mod 26 is essentially doing nothing because we have 3 plus a shift of, let's say, 5, and mod 26 will return the same thing. But let's say I give you a huge key. I give you a key, let's say 100. I'm clearly out of 26. What it will do is mod 26 is basically doing go to 26, go back to 0. 1, 2, 3, 4, 5, 26, go back to 0. Okay, it's working. It basically breaks down 100 mod 26, something like this. That is in 100. There are 20 in 100. Basically, you the first 26, one cycle is complete, ignore that. Another 26 cycle is complete, ignore that. The final 22 are important because we are within the cycle. Does anyone have a confusion with this? This is something called as modular arithmetic.
No, sir.
Clear? Satya also, I think you used this in you did mod 26, something like that. So mod 26, there the code that you wrote essentially works with lowercase letters because the lowercase letters are small a to small z, 26 letters. But we want our code to be working with capital letters as well. So therefore, in our case, this thing basically length of alphabet, this is 52, not 26. So we write this, so we get new index. Now, what do we have to do? We just return the alphabet, which is add new index. So let's see if this works. We have Python solution. Let's try a dummy. Dummy.txt. We write there. Let's try this. So we have this. We are doing encryption. Our input file is dummy.txt. We want to output it. Dummy out.txt, and the key is, let's say, 5. Module object is not called. Okay. Let's try this. So basically, it was unable to convert the map function directly into a string. So what we did is we converted that into a list, and then we changed the list into a string. Is that clear? I think we may be able to do it straight away as well. Yeah. So we get a map function and we convert the map function into a string. How we do it is we use this dot join. It works on an iterable, takes one letter at a time and joins them using this. If we had a space, it would put a space between everything. So dummy out has nothing in it because we had an exit. What is dummy out? Yeah, so this is dummy out. So let's see if decryption works. Now, notice that in encryption, can you hear me?
Yes, we can hear you.
Yeah, I think something's wrong with the mic. Was I audible all the way?
Yes.
Okay. So I was saying when we do encryption, we want to shift forwards. Okay, let's say I supply a key equal to 10, I want to shift 10 forward. In case of decryption, we want to shift backwards. So we just have to reverse the key. So we can say args.key if args.action is equal to encryption, else we use minus args.key. Simple as that. Now let's say we have Python solution. The action is decryption. The input is, in our case, dummy underscore out, and the output file will be, let's say, dummy decryptor.txt, key again 5. So what did we get? Hello there, Python. Okay, so let's try it on a bigger file. Delete. If text, let's remove these as well. Yeah. So let's say we have Python solution dash a encryption dash I will be text dash will be a cipher. And let's say we use a big key, let's say 1000. So cipher text cipher key. Yeah, so this is the ciphertext. Confirm whether we're working. Okay, we do this. Cipher output will be, let's say, the captain.txt and same key. And we get the same thing. Any confusions? One of you has their hand raised. Any question?
Sir, I designed this code, but the other way by the use of ORD and CHR. And I want to ask in something in my code that I don't able to change, decrypt or encrypt the some symbols like um, let me show you.
Yeah, let me give you the permission, wait. Yeah, try now. Can you unmute? We can't hear you.
Sir, I am visible now.
Yeah, your screen is visibly audible.
Sir, like you see, I use the ORD and CHR character to basically shift my decrypted or encrypted character by 3 or -3, and the like here I actually encrypt my characters into this, but
Yeah.
like something I'll copy. So that something like this happen.
Where is the text?
Hello,
Yeah, where is the text?
sir. Here is the text.
The functions, so on, so on. And where do you read it? Yeah, the part where you read the lines.
What?
Where do you read this text in your code? Show me the part where you read the file.
Sir, I actually can't hear you.
Am I audible? Can others hear me?
Sir, now you are audible.
Yeah,
Sir.
maybe we'll speak after the class because we have only 45 minutes and we still have 2 more questions. So if you have the time, we can stay on. Okay.
Okay, sir.
So does anyone have any questions with this? No. Okay, does anyone see? Okay, one doubt. Yeah. Okay, in your code. Yeah, we'll do it after class. Okay. So does anyone see any inefficiency in this code? A problem basically. let's say you work for the government and I give you a huge file, almost let's say gigabytes worth of text data, and I ask you to encrypt it using your algorithm. Okay, 50 gigabytes. Let's say you are working on a system that has only 8 gigabytes of RAM, and I give you a text file, which is let's say 100 gigabytes, which is very possible in nowadays. Okay, so does anyone see any issue in this in that regard? Yeah, I mean that's obvious memory error. Now where? In fact, why would you get a memory error? Can you explain that? Yeah, I know in reading the file, but why? Can you unmute? I mean, I'm only reading one line at a time. I'm not reading the entire file at a time.
Because file buffer would be storing all those lines you have read so far.
Yeah. So in fact, think about it. I'm reading one line, I'm mapping it, and I write it to disk. I don't store that line anymore. I'm going one line at a time. So in fact, that shouldn't be an issue even if the file is 50 gigabytes because I'm reading one line at a time. Right? Is that correct, Satya? Because I'm reading one line at a time, I'm only storing one line in memory. So I should be able to read 50 gigabytes. Yeah, but that's okay. I'm reading one line. Let's say my 50 gigabytes has a million lines, and I read one line. I map it, I write it to disk. That's it. And then I go on again and again. By the way, the buffer, even if the buffer fills up, it will wait. It will, let's say, pick up 100 lines. We will work on those 100 lines. When we are done, it will keep on bringing more lines. Like there won't be a buffer over. So the problem would be, let's say, I give you a 50 gigabyte line, but there is only one line or maybe two lines. What happens then? Your entire file is one line. So if I do this, file I.read lines, and I read a 50 gigabyte line, my RAM is only 8 gigabytes. It will never fit in the RAM. Okay. We are assuming here this code will work if our lines are short, which is the case here. Let's say these are short lines, right? Now, in case I never hit enter in my text file, everything is in a single line and I have 50 gigabytes of text in one line. So then this code will crash. This is suicide. So does anyone have any ideas how we can fix this? So the way we do it is we don't want to depend on the length of the line, okay? Because we don't know how big the line will be. We say that rather than here, read lines, instead of doing this, what we do is we always read a fixed length of text, okay? So what we do is while true, that is go in an infinite loop and read something, okay? Line I is, we say file underscore I dot read. Please press it. Oh, I'm not presenting. Thank you. Visible? By the way, in case any of you have a doubt, please unmute because your chat isn't always visible to me. Is my screen visible? Can anyone confirm?
Yes, it
Yeah,
is
as I
visible.
said, yeah. Please speak up, right? Because when I'm on VS Code, I'm not looking at the chat. I don't know if anyone has texted. So we ask it to read a fixed number of characters so that we are independent of the length of the file. So let's say we do file.read and then we supply, let's define a buffer here. Let's say we want to read 1 megabyte at a time. That is 1 into 10245 bytes. Okay. We ask it to read this much at a time. And now, because we are in an infinite loop, we need to make sure that we exit. Now, when do we exit? We exit when we reach the end of the file. The end of the file is marked basically by an empty character, an empty string. So we say if line underscore I is equal to this, you break out of the loop. Otherwise, we do as we were doing before. This, we do this. That's it, right? Let's try this out. We have encryption, it works. The cipher is like this. We have decryption, that also works, right? So is this clear? The difference between this and this. So we say this is suboptimal as it depends on the line size. This is independent of the line size. Yep. Does anyone have any confusion? Should we move on? If you don't have a confusion, raise your hand. Then we'll go on to the next question. Okay, so before we go ahead, I think there are different participants in different sessions. So I maintain a repository of this code basically that I cover in the live session. So you don't need to take screenshots or copy basically whatever I'm presenting. We have a repository here where whatever code we have in the session, you can access it. For example, we had week 2, the problems and the solutions. So you will have the code here. So in case you haven't joined in the previous sessions, is the link for the code. Similarly, if you want to access the live sessions, we also maintain those. So let's say we have this, we have playlist. So here we maintain the recordings of our live sessions. In case anyone of you wants to revise some material, we have the code as well as the recordings. So let's move on. By the way, can you access these two? If any one of you has joined for the first time, can you confirm? Yeah, sir, Mr. You have a question? Okay, so moving on. Second problem is slightly easy. So you have a file where we have stored a table like this. This is text, okay? And this bar basically is just made up of individual dashes, right? And I want you to read this text file and extract the data out of it and store it in a dictionary. Ignore the percentage, just store the alphabet and the corresponding frequency like this. Create a dictionary, okay? So let's use the same text file. I think I shared it earlier. So the text file, yeah, the text file. So use this for Q2. Wait, use. That would be Q3. You need a table. Let me give you the table. That's one. This. Can you see the table in the chat? You copy it and paste it in a text file. I want you to parse it and get the information in a dictionary. See if after pasting in a text file, it maintains the formatting of the table. And please confirm in the chat, basically, or maybe raise your hand or unmute so that I can know that you were able to get it.
I'm not seeing anything in the chat.
I did paste it in the chat. Can you check again?
Yeah, got it. Thank you.
Can you paste it in a file and check if the formatting stays?
Yeah, it is staying.
Okay. So the table contains the frequency of every letter, and there is a special key that is basically numbers, or let's say a hashtag or any special character. We want to maintain the frequency in that. So you already know the keys, that is 26 letters and one special. So I want you to parse this table and store the frequencies there, ignore the percentage. So let's take 15 maybe, because we're running out of time. 10 minutes should be enough, but let's see. You can reuse the R parse code from the first question to read the file in this case. Did anyone finish? Is anyone doing it? So let's start. Can you see my screen? Yes, no. Can you hear me?
Yes.
Okay, so let's reuse part of the code. We want to use an argument parser. We just need an input file. That's it. So what do we do with the input file? With open args.input we read and we say there's a file I. Notice that in this case we know that the lines are short, so we can read one line at a time. So we do for line I in file I dot read lines. What are we going to do? We notice that line 0 is a divider, line 1 has data, line 3 is a divider, basic line 2 is a divider, and so on. So the even lines are dividers, the odd lines have data. So we can ignore the even lines, okay? So what we will do is we enumerate instead of just iterate. So we enumerate, and if I want to is 0, that is even, we ignore the line. Otherwise, what do we do? Now let's print the line and see what it looks like. Okay, let us print line 9 and let's break here just to see the output. So we have Python solution, solution 3 in this case, solution 2, solution 2 I, and we work with, let's say, text. How do you have table? So it looks like this. Alphabet frequency. Notice that there is also a new line here because it put a space. So what we want to do is remove the new line. Okay, we don't want the new line. We want to remove these spaces between the characters. Okay, and spaces. So how do we do this? Let's say we have line I. We say strip. What strip does is it removes any new line character at the ends of the text. That is, if it were in the beginning, it would remove that. If it's at the end, we can remove that. So we can in fact do R strip, that is right strip, only remove the right hand side, but only strip will also work. Once we have removed basically this thing, let's print this. So we have print. Let's print this part and break. Okay, so the new line is formed. So now let's remove the spaces as well. So if we do a split, by default, it removes any white space when it splits it, and we get individual chunks. So the first chunk is just a bar, it's one string. Then we have alphabet, it's another string, and so on. If you do this, by the way, you want it to split on a single space. So this is a problem because it will also consider blanks basically as chunks. We don't want that. So we leave it at the default behavior. The default behavior is whatever white space you have, split on that. So when we do this, it splits on the white space. So this is the white space. Ignore that. A is one character. This is another character. 65 is another character. Okay. So now we have this. So what do we do? From this, if we store it, let's say like this data is equal to this, and if we were to print data, better type of data, so this and we break. It is a list, okay? It is a list and it contains 6 characters, I believe. Length of data 7. So table is like this. So 1, 2, 3, 4, 5, 6, 7. Okay. So we know that it's a list and we know that it has 7 characters. So the first one is, let's say, bar 1, and then we have an alphabet, then we have bar 2, then we have frequency, then we have bar 3, and then we have percentage. Okay, right? If we look at the table, bar 1 alphabet, bar 2 frequency, bar 3 percentage, bar 4 and bar 4. Okay, so let's see if this works. If it throws an error, yeah, no error. So we obviously don't want this bar 1, bar 2. So why should we declare a variable for that? Let's just use a dummy variable for these. We don't want this. We don't want this. We obviously don't want percentage. We don't want bar. So we only keep the alphabet and we keep the frequency. Now we store it in a dictionary. So let's say we have um, data is equal to a blank dictionary, and we say data alphabet is equal to integer frequency because that would be a string. And then if we print data integer frequency, what did we do? Print frequency. Invalid literal integer based frequency. Yes. These are integers. Oh, the first one is not basically this. So we also have to ignore the first line. Basically, the first one frequency is not an integer, so we can ignore this one. So this is 0, 1. So if it is this or I is equal to 1, we ignore, and otherwise we go ahead. Right now, we get A65, B12, and so on. Now we can print it like this as well. For example, for A comma B in data.items, we want to print A, then we do this, then we do this, and we receive this. Now there is a short form, basically do this, all of this. In Python, if you have an iterable and you want to print it like this in a pretty fashion, there is a library known as pretty print. Okay, short form is pprint. What we do is we say from pprint, and you can just write pprint and give it the dictionary. The rest itself. So we clear this, we write this, okay, you receive this. It keeps this in quotes because it's a string. It keeps the frequency as is because it's an integer. Any questions? Is everything clear? Yeah, I'm assuming the no is part of the questions. So let's go to question 3. Question 3 is, you have a text file the way we had in Caesar encryption. I want you to read the file and count the alphabets, okay? You have to create the dictionary which we earlier read from the table, okay? So I want you to ignore spaces, ignore new lines. Everything else is either an alphabet or it's a special character. That is, if it's a number, if it's a punctuation mark, something like that, it goes into the special tag. Otherwise, it's an alphabet. You should use lowercase only. Basically, small a and capital A, both of them should go into small a. So it is case insensitive. So the computation should be case insensitive. Ignore spaces and new lines from the text. That is, don't count the space as a special character or a new line as a special character. Everything else goes into special. So use the same text as in question 1 and create this table. Store this table into a file. Okay. Let's say I run it. So we don't have the file out here. So basically, if you have this text, you should get a table like this when you run it. Obviously, with different values for A, B, C, and so on. So first, do this part. Then you have to figure out how do I format this dictionary into this and write it into basically the file. Now, before you go ahead, I want to show you something. Your lectures are actually following a different version of Python. It's an older version of Python. So let's do it in a file. Solution 3. Solution 3, 5. So you must have seen that in case you want to print something, let's say you have age is equal to 10 and you want to say my age is, and then you do this, then you format and then you write age here, right? So you have Python solution, and let's say my age is 10. Is that correct? Is this how you do it? Can anyone confirm if this is how you do formatting of print statements? Anyone? Answer. So there's a better way to do this. That's called an if string. So rather than keeping these curly braces and then doing a format, what you do is you say print, put an F string here, something like this. Then you say my age is, and within the brackets, you write like this. When you have an F before a string, it knows that this is a special string known as an F string. Anything between curly brackets is seen as code, basically, not a string. It's a code. So it knows that age is a variable. It's not a string. So if I do this, it will produce the same output. But this is neat compared to this because let's say you have many of these 1, 2, 3, and you had multiple variables. You have to keep track. Okay, what is here? What is here? What is here? Rather, in this case, you can just write it here. Let's say age and age 3 or something like that. So maybe you can utilize that in solution 3 if you are doing solution 3. Okay, the class here is just waiting for the solution. So I pointed to the text that I want you to use for creating the table. Save the table in a separate file. Print it out, save it to a separate file. Take 10 minutes if you're able to do it. I think we may not have the time, and I'll just post the solution to GitHub. If you can't get to this part, at least get to this part and let me know. Once you read the values, check if you get the correct values. Write a custom text yourself where you know how many letters you were expecting. Insert spaces as well as new lines, and then create a dictionary to cross check that you are getting the correct values. This maybe you can do after class. Did anyone except Niroj get the first part done, computing the dictionary? Okay, so since we're out of time, I'll post the solution for this one on GitHub. You can cross-check your code and my code on that. Let me paste the GitHub link again. So I'll upload this week's answers there. So that's it for today. Does anyone have any questions? If there are no questions, I'll stop recording.